So tatapusin ko na lang yung last 15 slides ng Gen Chem, and then we're going to have a short rationale ng few questions lang din naman for testing sa Gen Chem. Pick up natin yung discussion sa chemical kinetics. When we say chemical kinetics, yun yung branch ng chemistry that tackles how reactions occur, particularly how fast and what the requirements of a reaction are. No? Last time, we discussed on the collision theory. Nang sabi ay kailangan mataas yung energy ng mga molecules at kailangan sakto yung kanilang orientation habang sila ay nagbubungguan para magkaroon ng chemical reaction. Dito naman sa transition state theory, there is an intermediate phase kung saan ang reactants, they will have higher energy and then they will transform into the transition state before they spontaneously transform again into the products. So, sabi dito sa ating transition state theory, rate, gaano kabilis ang reaction is dependent on the energy requirement of the transition state. So, anong ibig sabihin nito? Kung ang transition state which is required to form the products occurs at a lower energy level, then the reaction will be faster. Bakit faster? Kasi mas mabilis na maaabot ng mga reactants yung required energy level na iyon. Ano? And when they are able to reach that energy level, they become an intermediate and spontaneously transform into the product. Yung energy that is required by the transition state, this is otherwise known as activation energy. Okay, uulitin ko. The energy that is required for the reactants to form the transition state is what we call activation energy. If you will recall, yung principle ng enzymatic catalysis, paano nag-work yung enzymes. One thing that they do is they lower the activation energy so that reactants can reach the transition state faster. So when the requirement for the transition state is high, the reaction rate is low. Ulitin ko, when the transition state energy requirement is high, then the reaction rate will be slow. And if the transition state energy requirement is low, the reaction rate will be fast. Kabaliktaran. Okay. The next aspect of chemical kinetics will be the factors that affect the reaction rate. Ano yung pwede natin gawin para mapabilis yung isang reaction? No? Definitely, we're going to change the factors of the reaction. So first would be the nature of reactants. Ibig sabihin nito, we're talking of the substances themselves that go into the reaction. So in terms of its nature, we talk of reactivity, its physical state, and its energy of activation. When we say reactivity, kailangan nating i-recall ulit na yung ating substances, they will always try to reach a more stable configuration. And the more stable configuration is achieved when the valence shell has a total number of 8 electrons. Ano? So yung tendency ng ating ions, ng ating elements would be to partner with other elements so that they reach the valence shell of 8. So ano ibig sabihin nito? Kapag malapit na nilang ma-reach yung valence shell of 8, they are more reactive than the others. So that's one thing. Reactivity, we're talking of the octet rule, no? Yung valence shell of 8. And we're also talking of the activity series. Ulitin natin from our previous lectures na yung activity series, ito yung listahan kung paano in order yung mga elements as regard to their reactivity. So, mas reactive si sodium kaysa kay gold. Okay? Sodium is more reactive than hydrogen, so on and so forth. Ano ibig sabihin nun? Kung ang iyong element ay nasa baba noong activity series and you have a reactant whose location in the activity series is on the top, ibig sabihin the reaction will occur. Kabaliktaran naman, if your reactants, the member of the reaction is already at the top of the activity series and you introduce another reactant that is lower in the activity series, no reaction will occur. No? When we talk of physical state, ito lang ang dapat niyong tandaan. Reactions will tend to occur faster if they are in solution. Ulitin ko, yung reactions, mas mabilis silang mangyayari when the substance is introduced as the solute in a solution. Bakit? Kasi yung solvent molecules, they will try to agitate or produce movement in the solute so that there will be more interactions when they are in liquid state. Ano? So, substances in solution will react faster. Substances in solution will react faster and more efficiently than those in solid form. Ano? So, sino pinaka-reactive? Liquid. Less reactive, solid. If closed yung container, no? Ibig sabihin walang communication with the environment, gases will also react faster. But in nature, gases are almost always in communication with the environment. Kaya relatively hindi rin masyadong feasible yung reactions in a gas. So ulitin ko lang yung energy of activation. Energy of activation is the energy requirement to reach the transition state. If that substance has a lower energy of activation, that energy requirement is achieved faster, and therefore the reaction will proceed faster. Okay. Next would be temperature. Paulit-ulit to sa ating kinetic molecular theory of matter. When the temperature of a substance is high, then the heat energy in that substance might as well be high. Kapag mataas yung heat energy, those molecules, those particles will move faster. So, dito natin makikita, high temperature will almost always equate to high kinetic energy, high mobility, high collision frequency, and therefore high rate. Kaya sa ating pag-compound ng if ang ating substance small, one way by which we can the reaction is to heat the substance. Heating some substances also pose particular risks. Example would be the organic substances, hindi na usually heating yung ating way of speeding up the reaction. Or if i-heat man natin, dapat controlled heat with regards to time and the temperature. Next would be concentration of the reactants. So, ganito lang. Parang logical naman siya. kung mas marami yung ating reactants, mas mataas ang chance na mag-combine sila. Ano? That is stated in the law of mass action. Ano ang sabi ng law of mass action? It's a law stating that the rate of a chemical reaction is proportional to the product of the masses of the reacting substances, with each mass raised to a power equal to the coefficient that occurs in the chemical equation. So, dissect natin yon. Pag sinabi nating law of mass action, dito sinasabi kung mas marami yung substance, mas mabilis yung reaction. How will we describe that? First, you write the chemical equation. Okay? Sulat niyo muna yung chemical equation. Next step, you balance the equation. Okay? Next step, you balance the equation. After you have balanced the equation, mapapansin nyo, some reactants will have larger coefficients than others. For example, 2Na, tapos yung isa ay 1Cl. No? So, yung larger coefficients, they will naturally have faster reaction rate. Why? Because yung mass, noong reactant, you're going to raise it to the power of the coefficient. So in the chemical equation that is balanced, the larger the coefficient, the faster. The larger the weight of the material, the greater its mass, the faster also is its reaction. So, paano natin ito ma-apply in the laboratory? If we're going to produce a certain product, if yung product lang yung habol natin, we can saturate the amount of the reactants. So, pwede nating dagdagan, especially in precipitometries, pwede nating dagdagan lang hanggat ma-form yung product. Kasi by adding more reactants, we're speeding up the reaction. Next would be under concentration of the reactants. A higher concentration of reactants, the higher the rate. So yun yung simple way of explaining the law of mass action. But take note, guys, etong increase in the concentration of reactants equating to an increase in the rate of the reaction, this is only applicable to first-order kinetics. So first-order kinetics, which is the nature of the body, the human body in eliminating drugs via metabolism, usually first-order. Pag magbibigay ka ng gamot, kung mas marami yung binigay mo, mas mabilis din siyang tanggalin ng atay. Magko-compensate ang atay. It will also speed up to eliminate more of the drug that you've given. However, there are instances where we observe zero-order kinetics. Pag sinabi nating zero-order kinetics, that system will remove or will metabolize a particular amount of substance per unit time. Kahit dagdagan mo yung concentration noong reactants, definite lang yung matatanggal niya through unit time. For example, alcohol, especially if given in high concentration, will exhibit zero-order kinetics. So ano ibig sabihin nun? Pag mas marami yung ininom mo na alcohol, mas matagal din siyang magsistay sa katawan. Whereas, if mas marami yung ininom mo na, let us say, heparin, kung mas mataas yung, mas marami yung na-inject sa'yo na heparin, the body will compensate by eliminating more heparin per unit time. So that's the difference between a zero-order and a first-order reaction. Etong increase in concentration of reactants equals increase in rate, that's for first-order reactions. Okay. So now we have the rate law expression. The rate law expression. So Dito, makikita natin we have reactant 1 and reactant 2 and its coefficient of reactant 1, coefficient of reactant 2. This is in correspondence to a balanced equation forming the products. Ngayon, tingnan natin paano ba to i-interpret, no? Sinasabi dito na yung bilis ng pag-form mo ng product is equal to how much reactant you have raised to their respective coefficients in the balanced equation. So, the rate of forward reaction, ito yung rate of forward reaction, is equal to the rate constant, which is dependent on the particular substances that you are combining or to the particular method that you are using, no, to combine the chemicals. So, the rate constant multiplied by the amount of product 1 raised to its coefficient and the amount of product 2 raised to its coefficient. So, kung mapapansin ninyo, if our products also decompose back towards the reactants, ano? Kung nag-form ka ng product and that product decomposes into the reactants, you have a two-way equation or a two-way reaction. No? So, ngayon, pwede mo nang i-equate ito to the rate law expression for the products. And later on in Le Chatelier's principle, we are going to look at that. No? So, kung mapapansin ninyo, etong law of mass action is similar to the rate law expression. Similar but not the same. No? Dito, we are talking of one direction in the rate law expression. We're talking of, in a chemical reaction, unidirectional. Dito, wala siyang regard to direction. Kung mas mataas yung reactants, edi mas mabilis yung rate. No? Mas marami yung reactants, mas mabilis yung rate. Okay. Guys, please memorize. There's no other way. Please memorize the formulae for the orders of reaction. This is for our first order reaction. Anong sabi natin sa first order? Yung reaction mangyayari mas mabilis if our concentration of the reactants are also higher. No? Mas mabilis yung reaction if mas marami yung reactants. So kung papansinin ninyo, tingnan natin to ha. If we are going to isolate T, transpose natin itong 2.303 sa taas and yung K sa baba. No? A, initial concentration of A times 2.303 over concentration of A final times K. That will give us T. So, nag-algebra lang tayo dito, ano? Kung mapapansin ninyo, if I have a higher amount of initial, if I have initially a larger amount of the reactant, pansinin nyo kasi numerator to, yung AO. If this is larger, and ito yung reactants at ito yung product. Okay, so ulitin ko. Yung AO, ito yung reactants, dami ng reactants, and A, dami ng product. Initial, final. If I am going to transpose such that I will have T, no? Kung i-isolate ko yung T, you will find out na yung bilis, no? Yung rate natin, it's dependent on how much there is in the initial amount of the reactant. No? Kung mas malaki to, mas mabilis. Half-life, please memorize 0.693 over K. Half-life, 0.693 over K. Although in the board exam, very rare na ang mag-compute ng half-life and plasma concentration computations. Usually, hindi na nagtatanong ng pharmacokinetics masyado. But we never know what will come out. So please remember for first order, half-life, this one. If meron mang question on the orders of reaction, it will usually be half-life questions. No? So for half-life of first order, 0.693 over K. Drugs, most drugs, no, will exhibit first order. Konti lang yung zero order. What is the usual pattern? If I give too much of a drug that is eliminated by a first order, it will saturate all the enzymes in the body and will convert to zero order. So kahit first order siya, kapag low yung amount, if you give too much of the drug, it will be eliminated by a zero order later on. Kasi nasa-saturate ng ating metabolizing systems. Okay. So kung mapapansin ninyo, for zero order, if we isolate T from initial to final is always a constant amount, no? From initial to final, that's always a constant amount. So for zero order reactions, the system, usually the body, will eliminate just a definite or fixed amount of the drug. It will produce a reaction which will form a product. Sakto lang, all of the time. For example, for alcohol, we have 17 grams per hour. You take more of that, you experience the hangover for more hours. Okay. So ang catalyst natin, these are substances that are not, take note, pakisulat ninyo sa inyong slides, catalysts are not used up in a reaction. Ulitin ko kasi very important, ulit sa exam, catalysts are not taken up or used in a chemical reaction. When they are taken up, they are reformed. So hindi talaga sila participants, hindi sila reactants. So catalysts will increase the rate by lowering the energy of activation. And balikan natin, if the energy of activation is already low, the reactions will proceed faster because more of the reactants will transition into the intermediate form and form the product. So ulitin ko, lower energy of activation, there will be an increased rate of the reaction. So that is what is done by a catalyst. A catalyst will also make a reaction proceed in a multi-step process. So, for example, this is usually observed in organic chemistry. So, if you have one reaction, let us say the formation of a carboxylic acid, and you have the reactants alcohol and an alkyl chain. So if you use an enzyme or a catalyst, the formation of the carbonyl group for your carboxylic acid will proceed in 2 steps. Whereas if walang enzyme, kailangan niyang i-form yung carbonyl in just 1 step. And remember, the formation of a carbonyl carbon requires so much energy. So, ito yung ginagawa ng ating phosphokinases in the body. So, biochem na yun, wag na natin yung i-touch. No? So, a catalyst, kung mataas yung kailangan na energy, for the reaction to occur, a catalyst will chop up the reaction. Reaction 1, then reaction 2. So it will proceed at lower energy requirements kasi spinlit up mo yung reaction. No? So, ulitin ko, catalysts are not spent in a reaction. Another board exam question will be, what are our biological catalysts? So pag sinabi nating biological catalyst, you think of the enzymes. No? And you have a separate topic for enzymatic catalysis. Ulitin ko, the surface of a molecule is where the reaction occurs. And therefore, if mas malaki yung inyong surface area, more of the active groups in a substance will encounter each other. So more active groups encountering each other, more reactions will happen. Increased surface area will mean an increased rate. So, paano natin ini-increase ang surface area? We make the material into smaller particles. So, we do that via comminution. Increased surface area, increased rate of reaction. So we do that by decreasing particle size, which is comminution. So in the same way, if you have a solution, the reaction will proceed faster if you continuously agitate the solution. If you stir the solution, the reactions will proceed faster. Why? Because the movement that you are doing with the stirring will introduce more reactants to an unbound area. Remember, yung surface area ng molecule, that is where the reaction will occur. Inside the molecule and on the surface of the molecule, if you continuously agitate the entire system, parang nag-replenish ba? Yung pasok ng reactants, labas ng product. Pasok ng reactants, labas ng product. So if there is continuous movement of the fluid, much of that interaction will occur. So faster ang ating reaction rate. So agitation in the physical pharmacy terms is by the principle of surface area. So next, we have the concept of thermodynamics and chemical equilibrium. So when we say that the Gibbs free energy of a system is zero, ibig sabihin yan, the system in relation to the environment, there's nothing happening. Or there is something happening, but it is opposed at an equal rate or at an equal magnitude. So the kinetics, no, if you are going to translate thermodynamics into kinetics, when we say that the Gibbs free energy is zero, the rate of the forward reaction is equal to the rate of the backward reaction. When the Gibbs free energy of a chemical reaction is zero, the speed by which you form the products is equal to the speed by which the products become the reactants once again. No? So that is your Gibbs free energy of zero. In terms of solutions, no, if you take note of a saturated solution, ibig sabihin, yung maximum amount of solute is already dissolved in the solvent, so saturated. Kahit hindi mo nakikita macroscopically that there are particles, that there are crystals being formed. Molecularly, crystals are being formed at a particular rate and being dissolve rate. Kaya hindi mo siya nakikita. They are formed, crystals are formed at a particular rate, and they are disintegrated into the solution at an equal rate. Kaya hindi mo siya nakikita in a saturated solution. Okay. So, another important concept in producing efficient chemical reactions is our systems must be homogeneous. Ano ibig sabihin? If you are going to have a reaction between a solid and a liquid, mahirap mangyari. But if both are in liquid phase, the reaction will occur much faster. Also, at the other end, the reactants and the products will have a faster reaction if they are both in the same phase. And that is our homogeneous system. No? So, describe na natin yan previously. But let us say your reactants are in liquid, and when they form the product is a solid. If the product is continuously being removed, if yung precipitate tinatanggal nyo, then the reaction will proceed faster. Ulitin ko. Solution in liquid form, reactant 1. Solution in liquid form, reactant 2. Let us say an acid and a base. When they combine, they form a salt, which is usually a solid. Ngayon, pwede mong pabilisin yung reaction if the solid that you formed, you remove. Ano? So, mamaya sa Le Chatelier's principle, makikita natin yan. So, ulitin ko, the reaction will proceed faster if the reactants and the products are in the same phase. So, yung solid na yon na na-form, that will slow down the reaction. So, remove that para mas mabilis yung forward reaction natin. A heterogeneous system, the reactants and the products are in different systems. Ito yung sample natin for the neutralization reaction. Forming is bleed salt. So, in the board exam, when you encounter a heterogeneous system for chemical equilibrium, ibig sabihin magkaiba yung reactants and products, kaiba yung phase. Usually we are talking of gases. Heterogeneous chemical equilibrium, we're talking of gases. Okay, so nag-review na lang tayo nito, no? The formation, so sabi natin last time, weak acids in general, they have different definitions according to the theories that are used. But let us take the Bronsted-Lowry theory of acids and bases. They are acceptors and donors of protons. So an acid is a donor of a proton and a base is an acceptor of a proton. So when we say Ka, we're talking of the acid dissociation constant. The organic acid, A, the proton, H. When we say Ka, gaano kabilis mag-separate yung A at saka yung H. No? When we say base dissociation constant, gaano kabilis kumuha ng proton ng base. For Ka, yung pagkawasak and pag-release ng proton. For Kb, yung pag-accept ng base ng proton. So, remember, Ka and Kb can only be determined if they are in liquid form. No? Ka and Kb can only be determined if they are in the liquid phase. Kasi we're talking of dissociation. Ibig sabihin, the larger particle dissociates with the solvent, which is usually water. Okay. So this is our common ion effect. So when we say common ion effect, for the exam question, please remember this one. Palaging lumalabas. The presence of a common ion suppresses the ionization of a weak electrolyte. So tingnan natin itong example na to. You have acetic acid and water forming acetate and hydronium. So ang ating acid is this one. Ang ating base is this one. This is our conjugate base and this is our conjugate acid. Okay. So tingnan natin yan. When we add hydrochloric acid, HCl, what will happen? More of the protons will be added into the reactants. No? More of the protons will be added here. If the proton in the hydrochloric acid combines with water, H2O, so tingnan natin to. Originally, acetic acid is the one that combines with water to form hydronium. But if you add hydrochloric acid here, another proton donor will be present. And that proton will be accepted by water, forming hydronium. So mas marami yung na-form mo na hydronium kaysa sa nung wala pang hydrochloric acid, kaysa sa nung acetic acid pa lang yung present. So ano mangyayari? The hydronium will exert pressure into this equilibrium. No? The hydronium will exert pressure here. So that hindi na magre-receive masyado ng proton from acetic acid yung water. Kasi kumukuha na siya from hydrochloric acid. And what will happen? This particular reaction, formation of acetate and hydronium, will proceed more slowly because hydronium will exert a backward force. So babagal siya. Bakit mayroong backward force? Kasi mas marami na yung hydronium. No? Bakit mas marami yung hydronium? Kasi nagdagdag ka ng extra protons than what was in the original. Nagaling lang sa acetic acid. Baliktarin natin. What if we add a base, sodium hydroxide? So, anong mangyayari? The hydroxide, OH, NaOH, yung hydroxide noon, will react with hydronium to form more water. So, ulitin ko. If you add NaOH here, the OH will react with hydronium and it will liberate more water. So that water here, kapag mas marami na siya, will interact more with acetic acid and therefore this reaction will be faster. Nakita niyo yun? Ulitin ko i-recap ko kung paano nangyari yung common ion effect. Una, ito yung ating normal state. Next, what if we add acid? What if we add proton? The proton will be accepted by water, no? And that water will form hydronium. Mauubos yung water, dadami yung hydronium. So ang mangyari, magkakaroon ka ng mas maraming reactants at this side, and therefore what is our law kanina sa rate law, the rate expression law? If mas marami yung ating reactants at one side, it will have a faster reaction than in the other side. So add tayo ng proton, more of this reactant, the reaction will proceed much faster going this way, going towards acetic acid and water. Next, what if we add a base? The base will be taken up by hydronium forming water. So, kapag nag-add tayo ng base, mas dadami yung water. And therefore, by law of mass action, the rate law expression, this will have a much faster rate going to the right forward. Kasi mas marami na yung ating reactants at this side, which is water. Paano yun? So, ganun ang ating common ion effect. If you have a particular ion in one side, if that particular ion is formed at a much faster rate, then that will suppress the same reactant. Kung ano yun? Parang paulit-ulit ko na siya sinasabi. Let me rephrase that. The presence of the common ion, hydroxyl, forming water, proton, forming hydronium, will slow down the ionization of that same moiety. So acid will slow down acid, base will slow down base. Okay? If you add sodium chloride, wala man siyang, papansinin niyo, if sodium chloride is added here, there is no sodium, there is no chloride here in the chemical reaction. So it will have no effect on the rate. No, no shift in the reaction direction. Kaya yun, yung common ion effect, ang gusto ko maintindihan ninyo. Kasi pagdating sa boards, ano na lang, intindihin nyo na lang. Huwag nyo nang alalahanin dahil mas marami yung constants na kailangan nyo maalala. So, ayun, alay nyo na sa comprehension. Okay? Okay. Balikan na lang natin. KSP is the solubility product constant. So, that is the product of the concentration of the different ions in a solution. If that is achieved by the solute, that level of KSP is achieved by the solute, you form a saturated solution. If more of the solute is present in a solution, much more than the KSP, then that is a super saturated solution. And if you have less solute than the KSP, that's an unsaturated solution. So, dito naman, we're talking of complexes. Complexes are molecules by which they hold other ions or atoms into their structure. So you have a big structure. Example, ito yung ating chelating or complexing agent. Etong spaces ng fingers ko, ito yung pockets, no? So Kf is how fast this molecule takes up an atom, usually a cationic substance. For example, for EDTA, it will usually take calcium, it will usually take magnesium, lead. No? So, how much of the how fast do I form the complex? That's the Kf formation constant. No? How fast do I form the complex if I add a metallic solution into a solution of a chelating agent? How fast do I form a complex when I add a metallic solution into a solution of a chelating agent. That's K. And last slide for this one would be Le Chatelier's principle. Anong sinasabi ng Le Chatelier's principle? Board exam question, please. When stress is applied in the equilibrium, the system will shift to relieve the stress. Parang tayo lang din. If sobrang aral ng aral, mag-accumulate yung stress, babawi tayo, mag-binge din tayo ng YouTube or Netflix. Parang ganun. But in chemical reactions, stress could be changes in concentration, pressure, volume, or temperature. So for example, we have here reactant 1, reactant 2, and the product. Okay? If I add more of A, there will be pressure in this side of the system. Increased pressure. So the reaction will proceed faster going to P, to the product, to relieve the pressure here. Same as with if I add reactant number 2. Kung dadagdagan ko yung B, tataas yung pressure dito, and the system will shift towards the right, faster reaction towards the right, faster forward reaction forming the product, so that the pressure here is relieved. No? Kabaliktaran naman, if I add product P, no? If I add P, more will be the pressure in this side of the system, and it will be relieved by making the reaction, which is the decomposition reaction, towards this side of the reaction much faster to relieve the pressure here. What if baliktad? If I remove A, kung tatanggalan ko yung product 1, there will be less pressure in this side kasi tinanggalan ko. And therefore, the backward reaction will proceed at a faster rate. If I remove P, which is what we do in precipitometry, we filter, di ba, the precipitate. If we remove P, the pressure here will be lower and the pressure here will be higher. And therefore, the forward reaction will proceed at a much faster rate. Okay? So that's for concentration. What about pressure? When we increase the pressure in one side, no? If we increase the pressure, the force acting on all directions, what we're essentially doing is we're decreasing the volume of the reactant. So for example, if ito yung volume, parang Boyle's law. If ito yung volume ng aking system dito at the reactant side, at this particular pressure, if I add more pressure, the volume will collapse. And therefore, mas magkakadikit na ang inyong reactants. No? Mas magkakadikit, mas mag-i-interact. And therefore, that pressure will be relieved if the reactants combine. If the reactants undergo a chemical reaction and they form the product, that pressure, that interaction will be relieved. And therefore, if I add pressure here, no, the volume will decrease, more interaction, more P, more product formed, faster ang ating forward reaction. If I add pressure here, more of the product material will interact with each other or with the environment, decomposing into our reactant 1 and reactant 2. Okay? So you have here the interrelationship between pressure and volume. If you have lesser volume, then that means the reaction will proceed faster. Ibig sabihin nun, more of our reactants are in close contact, in close proximity. Okay. What about temperature? If I increase the temperature here, more movement, more interaction, more collisions, more product formed. If I increase the temperature here, more movement, more collisions, more chances of disintegrating. So I will be speeding up the backward reaction. What if I add, ito yung board exam question. What if I add a catalyst here? What if I add a catalyst here in the product side? What will happen? Will that increase stress in one side of the system? No, because catalysts do not participate in the equilibrium. Ulitin ko, catalysts are not used in a chemical reaction. Therefore, they will not participate in the equilibrium. Papansin mo dito, ito lang yung nagpa-participate. Reactant 1, reactant 2, and product. Ito lang yung in equilibrium. If you add a catalyst here, yes, the reaction will be faster, but the equilibrium will be the same. No effect in equilibrium. Okay, so we have already finished the lectures for general chemistry. We'll take a 15 or 10-minute break. Okay? We'll take a 10-minute break, and then when we come back, we're going to answer some questions. So I will flash questions, and then I will rationalize. I will try to answer the questions, and you listen how I answer the questions, how I eliminate the choices. So you have a gauge kung ano yung usual na board exam questions and paano siya hulaan in a way. Paano hulaan yung answer. So I'll see you in 10 minutes. Okay? 6 participants. Okay, so right now we'll be answering some general chemistry questions all throughout the different topics of general chemistry. Just so you can stimulate your memory, your learning of general chemistry, and so you can have tips and tricks kung paano mag-understand ng general chemistry questions. Okay? Okay. So ang aking resource dito for the more difficult questions, we'll be using the 2019 Chemistry Olympiad and some questions from the Review Center. So for this one, which sample contains the greatest number of molecules? So for us to, okay. So for us to understand this question, we need to recall ano yung gagamitin natin to determine number of molecules. And to do that, we're going to use Avogadro's number. No? So Avogadro's number says 1 mole of a substance contains 6.023 times 10 to the power of 23 number of molecules. So dito, hahanapin natin sino yung may pinakamaraming moles. So how do we do that? We get the molecular weight of the substance, and then we divide the weight of that substance by its molecular weight to get the number of moles. So for here, carbon will have a mass of 12 and hydrogen will have a mass of 1. So for letter A, 12 times 2 is 24. Hydrogen times 2 is 2, so we have 26. Ibig sabihin nun, 1 mole of substance A is equal to 26 grams, no? Letter B, 1 mole of substance B will have 32 grams. 32 grams is equal to 1 mole, and so on and so forth. So for this one, you divide, mm, 10. Yeah. Letter A, you have 20. Type dito. Tapos, 26. Lang hirap. Teka lang ha. Hanap tayo ng way. Dito na lang. Okay. And slideshow. Discard. I'm still presenting the screen. Ayan. Nakikita nyo ba na nagta-type ako? Wala nag-reply. Sige. Tingnan natin. Okay? So, to get the number of moles, chat. Teka lang ha. Hindi po.
Okay na, sir.
Nakikita niyo yung word na moles?
Opo.
Okay. So, ulitin ko, for this question, we're going to determine the number of moles. Ano? Kasi yung moles will allow us to convert into Avogadro's number, which will tell us how much number of molecules or particles of a material is present in its current mass or weight. So, for here, carbon is equal to 12 atomic mass units. Hydrogen is equal to 1 atomic mass unit. 1 atomic mass unit. So, for C2H2, we have 24 plus 2. Therefore, that's 26. Ibig sabihin yan, 1 mole of C2H2 is equal to 26 grams. So we have now the conversion factor. So next natin gagawin, we're going to divide 35 grams of that substance into our factor, which is 1 mole is equal to 26 grams. 1.34 moles. Okay. Next, same process. We have 24 plus 6 equal to 30. Ibig sabihin yan, 1 mole of C2H6 is equal to 30 grams, no? So next, we get 45 and input it into the factor. 1 mole is equal to 30 grams. We will get 1.5. Next, we have C4, so that's 12 times 4, 48, plus 10 is equal to 58 AMU, where 1 mole is equal to 58 grams. Next, we divide the factor, 60, 1 over 58. We get the number of moles, 60 divided by 58. 1.03. Lastly, let me check. Yeah, tama, 1.03. Lastly, so dadaanan ko na lang ha, pero you get the process, ano? C6H6. 12 times 6 is 72. 72 plus 6 is equal to 78. Where 1 mole is equal to 78 grams of that substance. Therefore, 100 grams input into the factor, 1 over 78. Give us, yan, very good, may nagchat-chat. 0.78. Calculator, confirm ko lang ha. Pero I'm sure tama ka. Of course, 0.78, ba't ko pa inaan? 0.78. Kasi 100 moles. Okay. So, if you have gone through this process, makikita nyo na yung may pinakamataas na moles ay letter B. That is why letter B is the answer. Okay? So, wala. Ano ba siya mag-show? Ayan, letter B is the answer. 1.5 moles. So, nakuha niyo yung process na yun, ha? You convert into moles. And you compare sino yung may pinakamaraming moles. Therefore, siya yung may pinakamaraming number of molecules. Next. A test tube is filled with 5 ml water, 5 ml carbon tetrachloride, and a few crystals of iodine. After capping and shaking, what is the final appearance of the system? Tama ba na nagsi-screen share pa rin ako? Noong question? Hindi ko kasi sure eh. Okay. So, we have an understanding question. Ano? Kailangan nating intindihan muna. What is our reaction here? Iodine will be reacting with water to form a violet liquid. Okay? Iodine will react with water to form a violet liquid. Ngayon, ang question dito, anong mangyayari pag dinagdag mo sa isang system that contains a polar water and a non-polar solution of carbon tetrachloride? So, ano yung parang phenotype or appearance na iyong mapoproduce? So, determine mo muna sino yung mas mabigat. Tubig ba o carbon tetrachloride? So the one that is heavier will be the polar water. heavier seawater, and because iodine interacts with water, it will be underneath. The violet liquid layer will be underneath. Carbon tetrachloride is lighter and therefore it will be above. Iodine interacts with water, therefore it will be violet in the inferior solution. So, nakuha natin yung process na yun, ha? So, single layer of violet liquid, no, because carbon tetrachloride and water are not miscible. Kasi water is polar, carbon tetrachloride is non-polar. A single layer of colorless liquid under violet vapor, no, because if added with water, a violet solution will occur. A violet vapor does not happen because iodine in vapor form is brown, hindi siya violet. No? So mali yung B. C yung answer natin. Invalidate lang natin si D. A violet liquid layer above a colorless liquid layer. Wrong. Because water is denser than carbon tetrachloride. Therefore, the violet liquid layer should be beneath the colorless liquid layer. Okay, so this is the chemical structure of cyclic adenosine monophosphate. What is its function in the body? No? Adenosine, this is the sugar, this is the base. No? Kaya siya adenosine. And this is the phosphate. No? Next cycle, kaya cyclic adenosine monophosphate. What is its function in the body? Yeah. Ang usual na mali ng students kasi adenosine monophosphate katunog ng adenosine triphosphate, iisipin nila na energy source to. No, it is a signaling molecule. It is a second messenger. So remember your pharmacology, if epinephrine binds to its receptor, it will stimulate the GS protein and increase levels of CAMP, which will increase the activity of protein kinase A, which will phosphorylate certain molecules in the cell, producing its anticipated action in the smooth muscles of the bronchioles, vasodilation. Vasodilation of the skeletal muscles, tama? Bronchodilation in the bronchi because of smooth muscle relaxation. So on and so forth. We'll discuss that in pharmacology. Product of DNA degradation, no. Our product will be the purines, remember? And some other molecules which biochem will discuss to you. Synthetic precursor of DNA, no. Those will be the nucleotide analogs, which are usually drugs for chemotherapy. Yan, signaling molecule. Right. Which element is the most electronegative? So, to answer this, you should recall your periodic trends. Paano yung movement ng periodic trend for electronegativity? Sige, answer lang kayo. Yep. So, electronegativity increases as you go to the right of the periodic table, and from the right of the periodic table, it increases as you go up. Next. Ayan, chlorine is the answer. What is the oxidation state of sulfur in sodium? This is S2O4. No, wala siyang ionic form. S2O4. Okay, what is the oxidation state? Kung mapapansin nyo, our valence is 0. So you should equate to 0. Per sulfate yata ito. Teka lang, check ko lang. S2O4. This is 2O4. S2O3 disulfate. Yan, may answer na. Oh. Oh, di ko nga alam yung ano na to. Teka lang. Bumaliktad. So, apparently, S2O4 is dithionate. No? Dithionate. Sodium dithionate. Yung pangalan ng compound na to. So how do we do that? No? We equate to 0. You have -8 and +2. So -8, +8, +2 becomes -2. So you have 6 divided by 2, +3. Yeah, +3. Okay, in which list are the ions ranked in order of increasing ionic radius? Increasing ionic radius. So, periodic trend ulit, no? Paano nag-increase ang atomic radius? May na bang nag-answer? Ay, teka lang na, bakit na ganito? Okay, sige, answer lang kayo. Si Denzel De Leos. Okay. So remember, ang ating non-metals, no? Ang ating metals, those that are in group 1, they have larger atomic radius. So, kung mapapansin niyo dito, yung ating group 1 will have larger atomic radius and therefore, eto group 2 na ito, calcium. So, hindi siya yung, siya yung dapat yung una natin. So, definitely, teka lang, nasa ng aking ano? Ayan. Since calcium is from group 2, therefore, it will have a lesser atomic radius than that in group 1. So, dapat siya yung mauna. Ito kasing ibang elements, they're already in group 1, di ba? Halina at kumain ng ribs, chicken, and french fries. So, strontium is also in group 2. So, dapat strontium yung kasunod. Okay, tama. Calcium, strontium. So, the first element should have the least atomic radius. So, yun yung pag-order natin ng question. As you go down the periodic table, atomic radius increases. So, between calcium and strontium will have a larger atomic radius kasi mas mababa siya doon sa ating periodic table, no? Nasa baba siya. So, lesser calcium, then strontium, and then we go to the elements of the first group, potassium and rubidium. So, di ba ang trend natin, you go to the left, atomic radius increases. You go downwards, atomic radius increases. So, sino mas mababa? rubidium, siya yung siya yung pinakamalaki yung ating atomic radius. So, group 2 elements, then group 1 elements. On top, on the bottom, on top, on the bottom of the of the periodic table. Larger atomic radius. Okay, next. A system which is confined in a rigid, well-insulated container undergoes a spontaneous change. What is true about the system? So, remember, we have different kinds of systems: open, closed, and isolated. First, alamin niyo muna anong klase siya dito. Rigid, confined. So, sure na tayo na it's not open. No? It's well insulated. Ibig sabihin, there is no exchange of heat energy. So, natatrap yung heat energy sa loob. Therefore, it's isolated. No? It's an isolated system. So, kung mapapansin ninyo, if it's an isolated system, dapat walang tumatakas na free energy. So, ang nangyayari dito, the Gibbs free, kasi ganyan yan. Yung Gibbs free energy natin, di ba, lumalabas siya from the system. If it is a closed or open system. So, dito dahil isolated system siya, yung energy trapped lang sa loob, hindi nakakalabas. Therefore, there is no change in Gibbs free energy. So, A and B will already be wrong. Ngayon, C and D na lang ang ating pag-uusapan. Yeah, tama. What is our next clue here? It is a spontaneous reaction or change. Therefore, it must follow the second law of thermodynamics, no? Para maging spontaneous siya. The entropy in the system must increase. So therefore, our answer here would be letter C. Right. The process of liquid water freezing at -10 and 1 atmosphere pressure is freezing, ha? So ang ating unang isipin, paano nagmo-move yung heat? This is freezing. May nag-answer na ba? Wala pa. This is freezing. Are you gaining heat or are you losing heat? Bakit may nag-ano? Anong nangyari sa chat? Yep, you're losing heat. So, ibig sabihin, that's exothermic, no? So, ganyan lang mag-answer ng exam, guys. Isang fact, eliminate nyo na agad yung iba, no? So, isang fact lang nalaman nyo, na-eliminate nyo na yung dalawa agad. So, exothermic siya kasi we're losing heat when we freeze. So, B and D are not the answer, no? So, A and C na lang. Next, is this spontaneous or non-spontaneous? Is this spontaneous or non-spontaneous? Is this spontaneous or non-spontaneous? So recall niyo yung thermodynamics natin, no? If energy is lost by the system, will it be spontaneous or non-spontaneous? Ganun lang. Exothermic reactions Remember, you lose heat to the environment. Therefore, you're losing internal energy. Enthalpy decreases. Entropy increases also. Spontaneous and exothermic. Ito, analysis na naman. Ano? A cotton ball is soaked in liquid, hydrobromic acid, and methylammonium. Same time, opposite ends of the glass tube. What will be observed? Okay? Saan mo daw makikita yung white ring, which is the product? Chat. Saan yung chat natin? Okay. So the first step here will be to determine what the product is. Will we form this one? Methylammonium or ammonium bromide? Etong product na to o etong product na to? Remember, naka-plug yan. So, ibig sabihin, walang dapat mawala. Hindi dapat mawala yung methyl radical. No? So, definitely, hindi ito yung answer. Dito na lang tayo sa dalawa. Okay. So, dito, maa-apply nyo yung Graham's law of effusion. Kung sino yung mas mabigat na gas, siya yung mas mabagal gumalaw. So, sino ang mas mabigat? Si hydrobromic acid or si methylammonium? So, paano nyo malalaman sino mas mabigat? Kunin nyo yung molecular mass. No? Mag-ano kayo? Wag tamad-tamad. 12 plus 3 plus 7 plus 2. Bromine is around 40-50. So yun pa lang, alam nyo na mas mabigat si hydrobromic acid. Therefore, hydrobromic acid will move much slower and the ring will form closer to hydrobromic acid. Ayan, closer to hydrobromic acid kasi mas mabigat siya. Ibig sabihin, hindi naka-travel yung gas kasi mas mabagal. Quantum mechanical model, paki-answer. Meron pa ba? Pa tayong participants dito? Meron pa. Quantum mechanical model. Ibig sabihin, di natin alam nasan siya, yung electron in the cloud. Sino may sabi nun? Erwin Schrödinger. No? So, ito yung recap natin. Si John Dalton, billiard ball. Atom is an indestructible sphere. Joseph Thomson, raisin bread. Atom is a sphere of positive particles in which negative particles are embedded. Parang raisin bread. No? Ernest Rutherford nuclear model. The atom consists of a large empty space kung saan yung space sa gitna is where the mass is. And this is where the positive charge is. That's the nucleus. Ernest Rutherford nuclear model. Niels Bohr planetary model. Electrons move around the nucleus in circular orbits. Parang orbit around the sun, the planets. Schrödinger quantum mechanical model, electrons are in 3D space, which we call orbitals, and hindi natin malalaman nasan sila. Answer na. Okay. Atoms with the same number of protons, but different number of neutrons. So same element, but different atomic mass. They are isotopes. Okay? Isotopes. Yan, answer. Yes, correct. Define na lang natin. Isotone, letter N, same number of N neutrons, different number of protons. Isobars, same mass, different elements. Same mass, different elements. Isomer, same molecular formula, different chemical structure. Isosteer naman, ito rare to, pero baka itanong, isosteer, similar molecular characteristics, so physical, kanyang mga colligative properties very similar, but they are not structurally related. Example, benzene and pyridine. Ito, marami nitrogen, ito wala. But same molecular characteristics. Same in the body can cause leukemia. No two electrons can have the same set of 4 quantum numbers. Sige nga. I-call natin yung ano.
A.
A. No two electrons can have the same set of 4 quantum numbers. Answer will be A. Correct. Pauli's exclusion principle. Very good. Nakikinig kayo. Di kasi ito sa slide, di ba? Sinabi ko lang ito. No? Hund's rule. Review na lang. Orbitals are filled up singly before pairing up. Okay. Aufbau. Lower energy levels are filled up first. Principal 1 before principal 2. Heisenberg's, di mo malalaman nasan yung electron. Sorry, hindi ko na-hide yung ano. Chalcogens, group 6A. Group 4A, other name, pakisulat to guys. Itong table na to. Bibigay ko naman yung slides. 4A, crystallogens, crystal formers. Example, carbon and silicon crystals. 5, pnictogens, ang other name. 7, halogens, salt formers. 8, you have the noble gases. And 3A, icosagens. Ano ibig sabihin ng letter A sa grouping? Ano ibig sabihin ng letter A? Pag nakasulat letter A, group 2A, 3A. Ibig sabihin, they are representative elements. They will follow the valence shell. No? They will represent the characteristics of the valence. Okay, ito, board exam question ito ha. Also known as ECA aluminum. Also known as ECA aluminum. Ibig sabihin, kagaya ng aluminum. Okay. Yep, correct. ECA, ibig sabihin yan, kagaya, similar properties. Kasi noon, wala pa silang way of determining the atomic number. No? Nakita lang nila itong substance na to, very distinct yung property niya, yung chemical, physical properties niya, wala siyang kapareha. And that is the way they found out what elements were. So noon wala pa, hindi pa ma-determine ano yung atomic number, atomic mass. Nung time ni Mendeleev. Kaya yung kanyang pag-order ng elements ay depende sa timbang nila. No? So, ang nangyayari, merong mga elements na akala nila ay compound of another element kasi similar yung properties, Pero nalaman nila na it's a different element but with very similar properties. So, kaya siya gumagamit ng eka. Ibig sabihin ni gallium, kagaya yung properties niya with aluminum. And there are other ekas. Germanium, eka silicon. Scandium, eka boron. And technetium, eka manganese. Noong time na hindi pa nila alam na ito yung mga elements na ito. Ito lang alam nila, kaparehan ni silicon but a different element. And substances that can act as either an acid or a base.
E.
E. Okay, so meron tayong definitions. Amphi, ibig sabihin both, no? Yun ang pag-determine natin ng amphi. Amph, ibig sabihin both. Two properties, dual properties. Rationality dito. Ayan. So, ang magkapareho, pwede nyong i-interchange si amphipathic and si amphiphilic. They are the same. Amphipathic, amphiphilic, both hydrophilic and hydrophobic. Usually, ito yung mga organic molecules natin. They both have a polar group, a hydrophilic group, and a hydrophobic group. For example, recall nyo yung structure ng glutamate. Yung R group niya, yung dulo ng mga R group, the amino group, the carboxyl group, those are hydrophilic. But yung gitna, hindi. Hydrophobic yan. So, they both have hydrophilic and hydrophobic portions. Amphibolic naman, it's a pathway where you will see both catabolism and anabolism. So for example, that would be the Krebs cycle. Sa simula, anabolic. Acetate or acetyl-CoA will combine with oxaloacetate. So, anabolic forming citrate. But later on, citrate is oxidized continuously and catabolized back into oxaloacetate. So sa simula, may anabolism. Sa dulo, may catabolism. So, same pathway, but with anabolism and catabolism. So the Krebs cycle is an amphibolic pathway. Last would be amphoteric. Ito yung question. Substance that can act as either an acid or a base. Amphoteric. Ulitin ko, board exam question itong mga ganito ha. Mga amphi. So, amphoteric, substance that can act as either an acid or a base. A very specific definition for amphoteric will be amphiprotic. Ibig sabihin dito, we're talking of the Bronsted-Lowry definition. Can donate both. Can donate and can accept a proton. Amphiprotic. Amphiprotic is a specific form of amphoteric. Okay? So very good. Mukhang nakukuha niyo naman, no? Ito yung last slide natin for Gen Chem. So next time, I'll be using the remaining 4 hours for Gen Chem for pharmacology para meron tayong working time or meron tayong surplus just in case matagalan tayo. So the first lesson for pharmacology will be cardiovascular, no? Cardiovascular pharmacology. I'll try to parang make you understand. Kasi yung for the board exam, paulit-ulit lang yan. If you're, for pharmacology, you're able to classify, okay ka na, no? Alam mo lang yung physio, pathophysio, how to correct the pathophysio, and classify, okay ka na sa pharmacology. For the pharmacists, licensure exam, pharmacology is the easiest, definitely. Module 4 is the easiest for the PLE. So, relax lang tayo, no? For pharmacology. Cardiovascular yung una. Okay, thank you. See you next time. And si Ma'am Risa na lang ninyo yung mag-schedule. No? Okay. See you guys next time. Thank you also. Sorry, questions pala, no? While you were reading your general chemistry. Wala? Okay, sige. Magtanong lang kayo if meron kayong ma-encounter. For example, nagpapakok ba kayo? May kayo makita? Okay? Or nag-read ba kayo ng ano? Oh, ano yung question? Sorry. Check ko lang to. Okay, sige. Thank you. See you next time.